using your Rycom 8875 series locator. The ideal way to identify or verify an underground cable is to expose it, but this isn't always possible. A Rycom cable and pipe locator is the next best method. This video is intended to assist you in becoming familiar with your 8875 series locator. For more detailed instructions, it is advised to read the user's manual, as this video is not intended to replace the user's manual or your company's procedures and policies. When possible, review utility maps of an area. By looking for signs of buried utilities, much information can be obtained about the presence of underground utilities before a cable and pipe locator is used. The Rycom locating system uses two instruments, a transmitter and a receiver. The transmitter sends an electromagnetic field down a pipe or cable, and then a receiver detects the field, locating the utility in the area relative to it above ground. Over 70% of mislocates are due to improper use of the transmitter. Using the transmitter requires the greatest precision. If you can identify good connection sites and develop a good circuit, locating should be accurate and easy. The transmitter works by creating a circuit which is a complete circle of electric current. The electrical current must be able to flow from the transmitter down the utility to an earth ground and then return to the transmitter through the soil. The better the circuit, the more signal will be transmitted on the line. The transmitter can transmit signal to a utility and create a circuit using three different methods: direct connection, coupler induction, or transmitter induction. Out of the three methods, transmitting a signal by direct connection is the best method. Direct connection offers the greatest signal strength. It allows you to use either low or high frequencies, and it allows you to manipulate the grounding of the transmitter. Direct connection should be used over coupler induction and transmitter induction whenever possible. To create a direct connection, clip the red positive cord to a metallic conductor of the utility. This may include copper shielding, ground wire, tracer wire, pipe wall, or a fire hydrant. Never connect directly to a live electric line. Connection points vary depending on the type of utility you're trying to locate. Here's a quick reference. For more details, consult your owner's manual. Ground the unit by connecting the black negative clip to the grounding rod or a nearby metal object such as a parking meter or a street sign. It's important to ground away from the transmitter at a 90-degree angle from the line. Grounding away from the utility allows for a proper return path. Grounding near or over the utility may cause the outgoing signal and the returning signal to interfere. It is also important to avoid grounding over nearby utilities. This may cause the signal to return on non-target utilities, causing ghosting or interference. Ground away from other utilities. Ghosting and other interferences will be discussed in more detail later in this video. Dry, rocky, or sandy soil conditions create a poor return path for the signal. To improve the grounding conditions, water may be poured over the ground rod or a larger, deeper ground may be used. Both of these methods will increase the ground and help create a more reliable circuit. The greater the ground, the greater the signal strength. The transmitter takes about 5 seconds to determine the proper loading settings to use. Then the loading light will blink. The faster the loading light blinks, the better the circuit. If the loading light is blinking slowly, you should create a better connection, increase the ground, increase the power setting to high power, or finally, increase your frequency selection. Always try using the low frequency first. If the signal strength is weak, check your connection of the red lead. You may need to expose more cable surface area to clip to or scrape off more paint. Then try to improve the ground. If that doesn't help, select high power. And lastly, increase the frequency. With direct connection, the 8875 transmitter can transmit two frequencies simultaneously allowing the user to select the detected frequency via the receiver. Coupler induction is used when you can't use direct connection. This includes on an energized power line or a telephone line that can't be interrupted. To coupler induce, simply clamp the coupler around an accessible area of cable and select a high frequency on the transmitter. Rycom's FlexiCoupler will induce a signal at both low and high frequencies. Be sure to select the proper setting on the coupler, AF for low frequency, 815 Hz, and RF for 82 kHz, the high frequency. Rycom's rigid clamp coupler will only induce at high frequency. In order to create a circuit, both the near and far ends of the cable must be grounded. Without the utility grounded at both the near and far end, coupling will not work. Even though the transmitter is not grounded, you still create a circuit using the utility system's grounding. The energy flows down the cable, going to ground and returning through the earth to the near end ground, where it returns to the cable, forming a loop. Transmitter induction can also be used when direct connection can't. However, a transmitter-induced signal will have less signal strength and may be present on other lines in near proximity to the transmitter. To transmitter induce, simply place the transmitter on the ground over the pipe or cable with the arrows on the transmitter parallel to the buried line. The transmitter emits a field which couples to the underground cable or pipe. The energy travels down the cable and pipe to the far end, returns through the ground, and onto the utility at the near end ground. Transmitter induction only works at high frequency. As a result, all cables and pipes around the transmitter will carry the signal, making it hard to identify the target cable or pipe. Transmitter induction will induce both below and above the transmitter. Be cautious of interference from buried cables and overhead lines. You can also use transmitter induction to do a sweep. One person holds the transmitter and another holds the receiver. By moving together across an area, rotating each pass 45 degrees, you can sweep an area to locate cables and pipes. We've talked about the use of different frequencies, but we need to go into a bit more detail so you know the pros and cons of the frequencies. The high frequency, 82 kHz, is great at getting over different kinds of hurdles on the line. These can include anything from a sheath fault to rubber gaskets on water pipes to poorly conductive cast iron pipes. However, a high frequency can jump to a good conductor when you're actually trying to locate a poor one, so be cautious. The 82 kHz high frequency is also used for induction or coupling. The higher energy allows the signal to jump on a line. High frequency is not good for congested areas where many lines run next to each other because the signal can jump or bleed over onto nearby lines. High frequency does not work well over long distances. The high frequency's ability to jump onto a line also is a hindrance. A high frequency will self-induce or bleed over onto nearby lines, while a low frequency will stay true to the cable or pipe. The low frequency 815 Hz works well in a number of instances. These include on lines that conduct easily, in example, cable TV, telephone, and power lines. And since it stays true to the line, the low frequency is ideal for congested areas. Low frequency also works well over long distances. However, the 815 Hz low frequency does not overcome hurdles well, nor do low frequencies work well on poor conductors or for inducing. In review, it is best whenever possible to direct connect and use low frequency 815 Hz. By adjusting the ground, you can control the amount of signal strength on a conductor. High frequency should only be used when necessary. Coupler induction and transmitter induction only work with high frequency and do not allow for much manipulation that may improve the locate. Of course, using the transmitter properly is only half the task. You also need to learn how to use the receiver to locate correctly. The 8875 series receiver is designed to be highly versatile and user-friendly. The receiver locates the signal transmitted down the line. The amount of signal detected is displayed both visually and audibly. Visually, the signal is displayed both numerically in the signal strength window located here at the top of the display, and graphically here in the center of the display. By pressing the frequency button, you can scroll through the frequencies to match the frequency selected on the transmitter. Walk out about 15 feet from the transmitter and make a half or full circle around the transmitter to find a utility. Remember to keep the receiver pointed away from the transmitter tracing the circle. This will ensure the proper positioning of the antenna. It is important to continue your sweep after a tone is detected. Multiple utilities may be carrying the signal. Sweep the full area to determine your target utility. After you find the utility, move the receiver side to side about 2 feet in either direction to detect either the peak or null over the line. The 8875 receiver can detect the signal in either a peaking or a nulling mode. In peak mode, the tone, graphic meter, and numeric signal strength will read the strongest signal directly over the line and fade away on each side of the line. In null mode, the tone and the meter will read the strongest signal on each side of the line with the weakest signal directly over the line. Peak is more accurate than null. With interference, null can be drawn off slightly to one side or another. For this reason, peak mode is better for working in high interference situations such as near power lines or common trenching. It is important to keep the antenna perpendicular to the utility. The orientation of the receiver's antenna determines how it will read the signal from the line. When the receiver is not perpendicular, the signal will not be detected properly. Also be careful not to pendulum the receiver because this will affect the accuracy of your readings. Adjust the gain to receive the optimal amount of signal. When you find a line, tune the gain to a preferable level and then track the line both back to the transmitter and to the far end of the line. You may need to adjust the gain up or down as you get farther away from the transmitter and as the cable depth varies. If the gain is up too high, the numeric signal strength indication at the top of the display will blank out. You must turn the gain down. If the gain is too low, the receiver will not receive the signal. You then must turn the gain up. When no signal is displayed on the bar graph, by pressing the gain up button, the receiver will automatically jump to 90% signal strength on the bar graph. You can determine the depth of the cable in two ways. The first is to simply use the depth button on the receiver. Simply press the depth button while the boot of the receiver is resting on the ground, directly over and perpendicular to the line. The graph will blank out for a few seconds. LIN should appear in the signal strength window at the top of the display. If SON is displayed, the receiver is programmed to locate a SOND. To change the setting back to LIN, simply hold the Shift key while depressing the depth button. The depth is displayed at the top of the LCD. The 8875 receiver signal strength display must read above 400 to determine depth. The 8875 is programmed to determine depth to 15 feet. With interference, depth may be skewed and inaccurate. The receiver is designed to detect certain types of interference. If interference is detected, the receiver will read ERR, an error reading in the signal strength window. Caution must be exercised when using the push-button depth feature, as tilted magnetic fields and adjacent utilities can significantly throw off the measurement. Depth readings are not always accurate and should only be used as a reference. By using low frequency, preventing bleed over, and having the optimal amount of signal strength, depth readings may be more accurate. The second is called the 45-degree triangulation method. It is advised to always use 45-degree triangulation to verify push-button depth measurement. With the receiver in null mode, locate the cable, place the foot of the receiver at a 90-degree angle from the cable path. Position the unit so the bubble level on top of the meter is centered at 45 degrees. Pull the receiver away from the cable path, keeping the bubble level centered. When the locator indicates a null reading, mark the location on the locator's foot. The distance between the receiver and the cable path is the depth of the pipe or cable. By measuring depth on both sides of the utility, the user may determine if the magnetic field is tilted. If the 45-degree depth measurement is off by more than 6 inches between the two sides, then it is very probable the magnetic field may be skewed. A tilted field is called ghosting and may result in a mislocate. The only way to know for certain the depth of a pipe or cable is to expose the utility. In some instances, you may be in a field that has numerous utilities at varied depths. It's not unusual for the conductor connected to the transmitter to bleed off signal into a nearby conductor. This second conductor may produce a stronger signal than the target conductor because it is closer to the surface. To find the target conductor, locate the two conductors as accurately as possible. Standing over the first, press the current measurement button on the receiver. This will display a bar indicating the current strength on the LCD readout. Do the same over the second conductor. A second bar will appear. Whichever bar gives the highest level indicates the target conductor. To adjust the volume on the 8875A, hold the Shift key, while pressing the Mode key where volume is written in light gray lettering. After 10 minutes of non-use, the receiver will automatically shut off. Tips for an easy, more accurate locate. By following these suggestions, your locates may be more accurate and less difficult. The goal is to get the right amount of signal on the line without pushing out so much signal that nearby lines also carry the signal. Not enough signal means the line cannot be detected, and too much signal means other lines will carry the signal and interfere with the locate. The locator detects the electromagnetic field radiated off of the utility, not the utility itself. This field is usually circular, but when one conductor couples to a nearby utility, the field may become skewed. This is called ghosting and may lead to a mislocate. To avoid ghosting, use low frequency. Be cautious of grounding over the utilities and try to keep signal strength down. Be aware that locating cables is different than locating pipes. A pipe is continuously grounded while a cable is grounded at access points. A pipe will quickly lose signal strength as the current bleeds off the pipe to ground. A cable should maintain signal strength along the length of the cable. When possible, isolate the utility. Isolating the utility will decrease the interference and increase the amount of signal strength. Work from less congested areas to congested areas. Transmitted signals do not travel as well from the main utility lines to the secondary or service utility lines. Signal will travel easily from the house to the main or primary lines. Work towards the utility's source. A long extension of wire may allow you to reach a ground when surrounded by pavement. This may also allow you to create a closed circuit loop. By clipping the extension to the black lead and then to the far point of the utility, you can influence the path of the signal and increase the signal on a hard-to-locate utility. Passive locating with the 8875. The 8875 can passively locate the 50 or 60 cycles emitted from power lines without the use of the transmitter. Simply select the 50-60 cycle using the frequency selector button. 50-60 may be present on power lines, cable television, telephone, and water lines, but 50-60 is not always present. Be cautious. An energized power cable may not be detected. Passive locating cannot replace the dependability that comes from using the transmitter and receiver. Passive locating cannot isolate or identify cables. It is very common to encounter ghosting or skewed electromagnetic fields while passive locating. The 8875 is capable of locating a sonde. A sonde is a small transmitter available in different shapes and sizes, capable of fitting inside pipes and ducts. With a sonde, a user may locate a plastic, concrete, or cast iron pipe. The sonde transmits at 815 Hz. To locate a sonde, the receiver must be in peak mode and held perpendicular to the sonde. When locating, the receiver detects a peak directly over the sonde. To use the push-button depth function for sondes, hold the Shift key while pressing the depth button. SON will appear at the top of the display. That pretty much covers the basics of how to use your Rycom locator. With practice, you'll be able to locate the different types of utilities with ease. For more details on the function of the equipment and all the accessories available, consult your owner's manual. Thanks for watching.